So let me discuss a little bit about the this one. So this one is totally similar with the mid exam. And yeah, in this case, the value is 0.15 something. Some students answer like 0.16. Yeah, it's okay because it is the round up value. Because if you get the value, maybe it is like 0.159999 something. So that one, and the other things that I want to mention is the okay. I guess everyone understand the idea of this MAE and RMSE. Okay, okay, let's continue to this one. When we do with the first metric, okay, so let me review a little bit. We have several metrics like this one. You can evaluate the accuracy of prediction. The accuracy of prediction means I want to know the value, whether the rating is equivalent with the prediction of rating. So we have the MAE, RMSE, MSE, and MAE, and etc. We can also do the classification. So the classification means it is based on the categorical value. So the categorical means whether it is, for example, the user hit, okay, or the user like, or the user dislike. So if the user hit the item, it means okay, it is relevant. If it is not hit, then it is not relevant. So it is the categorical. And you already learned the precision, recall F1, precision at K, recall at K, average precision, and mean average precision. Okay. Now we are going to learn about rank. In the rank, we call this is accuracy of rank. So we have some measures like the rank score, leaf index, and DCG. Okay. So what is this one? Let's see. So when we discuss rank, it mentioned that the rank position matters. You know rank? Maybe we can say it is like the order. Okay. Sunfeng. It is the rank number 1, rank number 2, rank number 3, and so on. The accuracy of rank means we want to know whether the order is the same with the actual or not. So the actual is for a user, it is the sequence, or this is the order where the user liked the item. So for example, I know that the item 237, it is rank number 1. The item 899 is rank number 2. Okay. But when we predict when we recommend to the user item 345 is number 1, item 237 is number 2, item 187 is number 3. So how can we get this rank? Usually this rank is based on the rating. The higher rating, it can be rank number 1, or the least error. Okay. So if the error is very small, then we can say this is the rank number 1. So it has many variations. So we call this is rank matrix. The rank matrix extend recall and precision to take the position of correct items in the rank list into account. So this mentioned that the relevant items are more useful when they appear earlier. Earlier means if it is relevant, then if it is earlier or in the rank number 1, that is better. Particularly important in recommended systems, as lower rank lists may be overlooked by users. You know, overlooked is like similar to the ignore, musi. So if, let's say, you know, in one example in Kupang, when you want to search some products, Kupang will give you rank number 1, number 2, number 3. Do you want to see the product number 20? You don't want. Okay? Because it's too long. Okay? So that's also the same. The idea is we want to get the rank items which is higher, number 1, number 2, or number 3. So the rank score, sorry, this one, this one. So rank score is defined as the ratio of the rank score of the correct items to best theoretical rank score achievable for the user. Maybe the word is a little bit difficult. Okay. So we can see from this equation, there are 3 kinds of rank score. Okay. We call it, this is the overall rank score. The rank score is the result of the rank score P divided by the rank score maximum. So the rank score P, this is the equation, or we call this is the, this is ratio. We call this is ratio because we have 2 formula. The first formula is rank score P, and the second formula is the rank score maximum. So the rank score P, it means I want to know the rank score of the particular item. And the rank score maximum is the maximum that I have, or the maximum that I can recommend. So here you can see that X is the set of correctly recommended items. So X is the set of correctly recommended items. So for every I in the X, we want to do with this formula. The rank returns the position of an item. So T is this one, is the set of all items of interest. So if the interest, there are 20, then it will be like 20 items. And we have another variable. we call it alpha. So this alpha is the ranking half-life. It is given, so it mentioned as the ranking half-life, or this is the exponential reduction factor. So this is based on the kind of exponential distribution. When you have the rank, the distribution possibly is the exponential distribution. So we can use this exponential reduction factor to understand the rank score. The other equation or the other matrix for the rank is leaf index. So leaf index, it is based on the concept of deciles. Have you ever heard deciles? Maybe, yeah, it is very rare to use this decile. Assume that rank list is divided into 10 equal deciles, Si. So where the linear reduction factor is this one, and the leaf index can be measured like this one. So H is the set of the correct hits, and then we can measure how big is the leaf index of particular item. I think I have not give you any example of the leaf index, but let me just give you the concept of decile. What is decile? Do you know percentile? Percentile, we know this is the percent. Okay. What is the meaning by 10% of percentile? It means 10% from the total data. Okay. So we have the percentile like 10%, 20%, 30%, and so on until 90%. Okay. So this is also the same with that concept. In decile, we want to make into 10. Okay. So if we have this data, so we want to divide into 10 sections. That's why we call it decile. So how we can calculate into 10 sections? So you can look at the data. We have 12, 15, 16, 16, 18, 19, 19, 20, and you can see how many data do we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 20 data. Now I would like to know the value of the second decile. Second decile means, yeah, first we will divide those number into 10, and after we divide into 10, we want to find the second one. Okay. So it is the same with the concept of percentile 50%. What is the meaning by 50%? It is half. Okay, we want to divide into half, and yeah, if you want to measure the value of the percentile 50%, you will use median. If you want to get the value of the second decile, then first you need to divide the values into 10 sections. Okay, so 1 section, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And this is the D1. This is the D2. This is the D3, D4, D5, D6, D7, D8, and D9. If we know that the D1 is this one, D2 is this one, find the value of the second decile. It means this is the 7. Then the second decile falls between the score of 18 and 16 and 18. Then the value of the second decile will be 16 plus 18 divided by 2. Then the value is 17. In this case, we can say that the second decile is 17. That is 20% of scores fall below this value, and 80% are above. Okay, so it means 20% from the data is less than 70, and 80% of the data is higher than 70. So using the concept of leaf index, actually we want to check for every possible rank items. The other matrix, we call it the normalized discounted cumulative gain. Normalized discounted cumulative gain, or NDCG. Okay. I think some of your research papers, they use the metric, this one, the NDCG, to know whether the recommendation is good or not. We call it, this is the discounted cumulative gain, okay, DCG. It is based on the logarithmic reduction factors. The logarithmic reduction factors can be checked from this one. Okay. So the DCG pos, it means this is the relevant one plus the sigma of this one. Maybe, yeah, it's difficult to explain the formula. We will check the example for better explanation. We have the DCG, and then we have the idealized discounted cumulative gain, or IDCG, and we have the normalized discounted cumulative gain. It is based on the logarithmic reduction factor. This is assumption that items are ordered by decreasing relevance, and this number will be a normalization. So if you still remember in the normalization, I think if you learn in the data mining, you learn about the normalization. The normalization will give you a number between some value, we call it the minimum, and the maximum. Okay. In this case, we want to put the range between 0 and 1. So let's see one example. So this is a recommendation for a user. Okay, let's say just the user ID is user 234. Okay. And then there are 20 items. So 20 items is recommended to the user. However, the user only hit number 4 and number 20. So we need to check whether this recommendation is good or not. We use the rank score. The rank score here. First, we need to understand what is the ranking half-life or the alpha. You still remember alpha? This one. Okay. Usually alpha is given. Okay. So you don't need to consider how to get this one. But some research they mention that this alpha can be half from the number of the recommendation items. So if you want to recommend 20 items, you recommend 20 products, then half of 20 is 10. So we just make the 50% of the total recommended items. So most probably we use 50%. Then we can just put all the values into the rank score. So the rank score for the particular item, at first we need to make the formula 1 divided by 4 minus 1, 2 power of 4 minus 1 divided by 10. What is this? This one is from this one. The rank of that item. What is the rank of the item? This is the position from the 20 recommendation item minus by 1. So I want to know whether it is closer to 1 or not. And then divided by the alpha. Alpha is the ranking of life. So we have the item 4 that already or hit by the user. So we include in the first equation. And the other is item 20. We have this formula and we get this number. The other kind of measures, we want to find the maximum. Okay, so what is the maximum? The maximum is we want to know how many items that already hit by the user. So in this case, we have 1 and 2. Only 2 already hit. So we have this I is from 1 until T. T is the set of all items of interest. Because there are only 2 items of interest. So the first I is 1 and the second I is 2 and finish. We want to get the ratio. The ratio means the rank score of all the items, okay, all the rank of the item divided by the maximum. So the maximum is this 1.9. So we will get the value is 0.5. 6. So if it is closer, is higher, then yeah, it is better. We have the leaf index. How to measure the leaf index? In the leaf index, we have the item 4 and item 20. Okay. So using the concept of design, what is design? It is divided into 10. Okay. So if it is divided into 10, then we will check for every possible. This one, this one, this, okay. Wait a moment. We have the 0.9. So if it is the position here, yeah, this one is 0.9, why isn't 0.1? Wait a moment. Suddenly I lost this one. We call this is the decile. Okay. We have the, this is the first, this is the second, third, fourth, 5, 6, 7, 8, 9, 10. Okay. And then based on the formula, it starts from 1 and goes to 0.9 and then goes to 0.8, okay, and then goes to 0.7 and so on. Okay. So the first one is 1 multiplied by 1. It means if it is located here, it will be multiplied by 1. So it's the best. If it is located here, it is multiplied by 0.9. It is located here, it is multiplied by 0.8. If it is located here, it is multiplied by 0.7 and so on. So the last one, it will be multiplied by 0.1 or the least factor or the least weight. So in this case, I have one item in the 0.9 section of the decile number 2, and then 0.1 is located here. So in the leaf index, because there are only 2 items, so we divide with 2. And this is the leaf index 0.5. So the number of the correct hits. If the number here are higher, of course, it will be better. Okay. So we expect that the leaf index is higher. So let's see another example. In this example, I have 5 recommended items. 1, 2, 3, 4, 5. So it's more simple. And there are 3 which are relevant. So this one, this one, this one. So they are relevant. So let's assume that the half-life or alpha is half. Okay, half, then 5 multiplied by half, because we have 5 recommended items. It is 2.5, but maybe for better calculation, let's just round it to 2. So the 2 will be here, the alpha. And you know that we will calculate for every rank of particular recommended items. So here it is in the rank 2, 2 minus 1 divided by 2. This is in the rank 3, so 3 minus 1 divided by 2. And then 4 minus 1 divided by 2. So we get this rank score. And then the maximum is this one. So the maximum, because we have only 3 items in the among the 5 recommended items. So we have the formula. The first is 1 minus 1 divided by 2. So 0 divided by 2 is 0. 2 power of 0, it is 1. And then 2 minus 1, because this is the second item, and 3 minus 1, this is the third item. We have the rank score and we have the rank score maximum. So we want to get the ratio. So the ratio is this one. We have 0.71, so we can say it is better, okay, because the rank score is higher. You can see that if there are more hit in the recommended items, so usually the rank score will be bigger. And how we can calculate the leaf index? Using the concept desire. In this case, how we can divide into 10? We have only 5. Okay. So we will consider as 5. If the item hit and recommended in the rank number 1, then we will multiply with 1. If the second, then we will multiply with 0.8. If it is the third, we will multiply with 0.6. If it is the fourth, we will multiply with 0.4. If it is the last, we will multiply with 0.2. So we have 0.8 multiplied by 1, 0.6 multiplied by 1, and 0.4 multiplied by 1 divided by 3, because 3 items have been recommended. That also hit by the users. So this is the leaf index. So by looking at this one, we can also get the DCG, IDCG, and NDCG. So how we can get this one? The DCG, what is DCG? The DCG means we want to check the relevance of the recommendation at the position and a particular position, plus the sigma of the relevance of the particular items in the position divided by the log 2 of I. The log 2 of I, it is the position in the rank. We know that this is in the position 2, in the position 3, in the position 4. Then we calculate the log base to 2, log base to 3, log base to 4. It means this is the DCG when we recommend 5 items. So the ideal, what is the ideal? The ideal means it is assumption that items are ordered by decreasing relevance. So the ideal is we have only the best item minus 1. So the last one will be removed. So we call it the idealized. So we just consider the log 2 base 2 and the log base 3, and we plus with 1. So if you look at the DCG, we include every of the recommended items that hit by the user. But for the IDCG, we remove the last one and we put 1. Why? Because we want to make the normalize. So we assume that the last one, okay, the last option is the least one, or maybe this is the overlook, or something that user may not consider the last one. And we can get the NDCG of those equals to 0.81. So the idea is still the same. The higher is the better. So there is another possibility. If we want to change the ranking half-life alpha, is it possible to change not to 50%? Yes, that's possible. Okay? Because it is only assumption. So if I want to change into 1, what happens? So the same with the formula. So just divide by 1. Okay? And then this is also divided by 1. And okay, the rank score is this one, 0.5. What about the previous one? The rank score is 0.71. Okay. So what does it mean? So if the ranking half-life is lower, then the rank score is potentially lower. So that's why usually we want to make it like only half from the total of the recommendation. And yeah, this is just based on the experiment results. The rank score, it is based on the exponential reduction. Usually, but not always, is less than the leaf score, and the leaf score is usually less than the NDCG. So they have different concept. The first rank score is using the exponential reduction. Use the exponential distribution. For the leaf score, it is just using the linear reduction. But for this NDCG, they use the log. Okay, so those three are the measures that usually the recommender system researchers use in the paper. Maybe sometimes they use rank score. If the rating is like exponential, if the rating is like linear distribution, they can use leaf score. Or if it is based on the log distribution, they will use NDCG. So it depends on the distribution of the readings. Okay. Then I will stop first. Let's have a break.